So my background is a little bit circuitous. So I have my undergrad and graduate degrees are actually in music. They have nothing to do with tech. And I moved to Boston after my undergrad, which I did at Kenyon. Anybody? Anybody? Yeah. Kenyon. So I ended up moving to Boston after that, and you can't really get music jobs in Boston, so I lucked into a job at a software company that was willing to train me. I had some really amazing mentors, and one of whom took me under her wing, and she said, "You've got the brain for this, you just need the training." So I learned almost all of my technical work on the job. And I worked through a couple of different software companies as a QA engineer, so I was writing both manual and automated tests in various computing languages. When I started looking for my next opportunity in 2006, I was looking for something that had kind of an altruistic component to it. So I had a friend at our studio already, and he said, "You know what, the people here are really amazing, we're doing good stuff, why don't you come and talk to people?" And after like the first interview, I knew I'd found my tribe. It's kind of an amazing place. So I started as a QA engineer, because that was my background, and started then moving into the support side of things as well, because I was interested in what was coming in from the field to inform how we were testing the products. And so kind of grew into the role that I have today with one foot in support and one foot in QA. And I kind of learned R along the way on the job. Again, that's kind of my MO, to be able to solve problems like that. And I found it fascinating. I was coming at it from a software engineering side instead of a statistics approach. So I was coming at it a little bit funky, and that actually, I think, helped me a lot, because I don't actually understand a lot of the statistician. I understand their goals. I don't understand as much about their background, because I don't have that training myself, but I was able to help statisticians be able to use a programming language to do what they wanted to do, which to me is really, really rewarding, because I'm basically paying back what my mentor gave me when I first started out as well. So I find that really rewarding. If you're looking for resources to start with R or any programming language, by the way, I'm not biased against Python or anything else. I think you should use the tools that you have, right? Use whatever you've got. But if you're interested in learning more about R, we've got a lot of resources, obviously, on our website, on our studio's website. But there's a surprising number of meetups everywhere in all of the different towns. So you can go onto the Meetup website and look for our ladies, look for our user groups. Really easy to get started from the ground level, because all of those groups are really welcoming for beginners. So if you're interested, the resources are out there.
Great. Thank you so much.
Sure.
Do we have any questions from the audience to get us kicked off?
Hi. Hi. I really enjoyed your talk yesterday. I really love working in RShiny, but I've encountered a lot of resistance to implementing tools using that from my team, and especially my manager, mostly because nobody else on my team ever works in R or knows how to use it. Do you have any advice for how to convince people to start to learn how to use R and be more open-minded to use tools other than just Excel?
Yeah. Are you interested in convincing people to use the tools, or to actually adopt the outcome of those tools?
More so to be open to the idea of even having any tools that would live in R versus in other places that we already use.
Yeah, that can be a difficult thing to do. That's something that we encounter almost all the time. A lot of times you need some level of adoption to be able to drive that discussion with other people, to say, hey, you know, we've got 5 people here, and they're all using Shiny, and look what these wonderful things that we're building are. A-R-E. So I think what we try to do is to encourage people to see the outcomes and see the value of those outcomes, and say, look, we can solve this problem with this application I've just built. You know, use these inputs that are interesting to you, and look at this immediate graph that you can see. So a lot of times you can drive the adoption and the interest in learning how to do it by seeing how powerful it is on the other end. So if you have applications or our markdown documents that actually solve a problem, like the kinds that we were just building them sort of casually to see what was going on, until we realized, wow, we could actually do something with this. If you get to the point where you have a plot that is going to actually impact the way you do something, somebody might look at that and say, wow, that really actually solves the problem. How did you build it? And that can then drive a little bit of the adoption in terms of getting somebody to take a look at new tools, because new tools are scary, right? Human beings are kind of hardwired to not have to change because we're comfortable in our paths, and I don't think that's necessarily bad. But to get somebody out of that path, you have to show them the value and say, look, a couple lines of code, and look what we can talk about now. Oh, wow, how did you do that? Well, here are these tools that I was using. So it's not necessarily an easy road, but we found that, at least especially in the people that we talk to, it's all about showing the value and then working backwards to how it was actually built.
I think there was another one right up front. Right.
Hi.
Oh, hello.
So I'm just getting to the point in my career where I'm starting to be involved in hiring more. I've been asked to step in and be part of kind of more of those conversations, and I'm interested in your experience in mentoring and being mentored. I'm trying to hire somebody who can speak data science and also IT and have both of those experiences, but those people are tough to find, and that skill is really tough to hone. And so what should I be looking for, especially for women who are applying to this position? What are some markers that somebody is ready to step into that role and take on mentorship from me or from my team? How can I encourage that and get more women to apply to this position?
So you're looking for people who you think would be receptive to mentoring, is what you're asking?
Yeah.
Okay. So that's a really good question. I hire people on the QA side and I hire people on the support side, so I'm not usually hiring data scientists themselves. But what I tend to look for, and I think might be global across most jobs, is the interest in learning. So I try to hire people who are eager to learn new things, because it's very, very rare in my experience to have somebody who has a lot of IT experience and a lot of R experience. They're unicorns, right? If you find them, by all means, grab them. But somebody who's interested in learning, somebody who has sort of an analytic mindset, who doesn't necessarily has the skills but seems to have the potential, that can be sometimes hard to hire for, because what questions do you ask in an interview to find out if they're interested in learning beyond them telling you that they're interested in learning? But I try to ask open-ended questions to see if they've ever explored something like this before, if they've ever done something on the side. You have to be careful with they've done something on the side, just because people have different time constraints, right? There are people who are caring for older parents. There are people who are caring for children. They don't have that disposable time, so we don't use that as a gate. But if there is somebody who's taken a Saturday afternoon to go learn a new tool and they tell you about it, that's a really good sign. So for me, it's more about soft skills almost, the curiosity, because the skills, technical skills, you set them into a course or a really good book or a really good mentor, and people can pick it up. So I look for the curiosity.
So diving back into a little bit more of the technical piece, you had mentioned making sure that code is repeatable, scalable, and measurable. Can you speak more about that and some best practices in order to ensure that's the case?
Sure. So one of the reasons we are so gung-ho on the code part of things is, especially with open source, you can actually go into the code of an R package and see how they're solving the problem. And if you like it, adopt it. And if you don't, you're like, you know what, I think I'm going to fork this, or I'm going to rewrite this myself in a way to solve the problem that you need to solve for your particular organization. And you can also build on those. So there are a lot of packages out there that have dplyr as a dependency because it's so useful for tidying data. So that's part of the reproducibility part of it, right? Once you set it into code, every time you run that program, it should do exactly the same thing, which isn't necessarily the case if you're doing a lot of ad hoc work. So using certain other tools, it's a little bit more difficult to kind of reverse engineer how you got to that conclusion, whereas with open source code, you literally can go look through the code. In terms of scalability, code is pretty easy to change. So it's not set in stone. Again, it's very transparent. So being able to go into it and say, you know what, I've got this new business problem. Let me build on some of the routines I've already written before, expand on those to handle a new data set, to handle a new question that's similar enough that you can just sort of take a turn off of what you've already done. And in terms of the measurability, again, like in the talk that I gave, when you see the plot, and you see that you had a problem, and then you see you did something about it, and then you see the plot go back down. I love being able to prove that we've done what we said we were going to do. Sort of like, the last speaker talking about the guy who wanted to prove that he'd done something productive. You can actually do that in code. You run the same analysis and you say, yes, that worked, or no, it didn't, let's try something else. And you get almost immediate feedback on whether or not a change has actually helped. So for us, being able to do, you can do that in a lot of tools. I'm not saying R is your only way there, but for us, it's really interesting to be able to actually see into that. You can see exactly what somebody did. Everybody has visibility in my company to the projects I've done. Good code or bad code is out there. And getting kind of the feedback for improvement and getting the feedback for new questions that need to be answered in, hey, can I borrow your package that you just wrote for this problem? I think it will help me with that problem. It's a way to kind of be not only iterative, but also you can kind of build on what you've done before. And it actually shortens, once you get over the learning curve of a new language, it shortens your time to value with your own assets. And so obviously, we're very passionate about that.
So on a related note, you mentioned you can see the effects and the data of a change that you've made. When a change is pretty large, how do you know that you've monitored for long enough to see the full effects of the change? And how do you stop that knee-jerk, oh, it's not working, let's stop and do something else?
Yeah, that's a really good question, actually. So a lot of times when we're talking about support processes, we get really fast feedback. The tickets stop coming in. You can just see the graph, it's great. Or the tickets didn't stop coming in, maybe we didn't do the right thing. That's fast feedback. When you're talking about product changes, though, the IDE in particular has a pretty long development cycle between releases. But because it's open source and because we have preview releases, people will adopt it before it's actually sent out to the world for reals, so to speak. So we get a lot of user feedback. So if we make a change based on the kind of customer information we're getting in, and it goes into a preview release, the people who are using the open source version will tell us right away if it's not working, right? Probably about 75%, 80% of the features that we write are available in both open source and in the pro version, and so we'll get really fast feedback that way from the open source users if it's in that 80%. But to your point, when we're talking about pro-only features, we do have a really long cycle before we find out whether it works or not. So that can definitely be a challenge, but we monitor for it. We look for it after that process or after that release has happened, and so we don't just set it and forget it. We actually go back when the release comes out and we say, okay, is it actually having the effect that we need it to have? In some cases, we pull the plug because it's not. But in our case, because we are a small software company, if we find that it's not, we just iterate the next way through. So it's not too big of a risk for us because it's software as opposed to some of the more security conscious products that other people are building. So for us, there's not a huge risk. We just do the best that we can in our due diligence. Yeah.
Any other questions from the audience? All right, so we have one up at the front.
Hi, my name is Lucy. I work at Huntington National Bank with Jen. In response, I have something to add to your response to the person who asked the first question about how to get your team and eventually your company looking at R in a different mindset. I came from civil engineering consulting. I was an engineer practicing in the field about 9 months prior to now. And as civil engineers, we're not exactly the most innovative, techie people out there. So I was dealing with tons and tons of data at my last job, and I started realizing that crashing your computer about 8 times a day, yeah, you can charge that time to the client, but are you actually accomplishing anything? So I started incorporating R into my job. And it is hard when you're standing in a boardroom talking to directors about how you are trying to solve your client's problems efficiently because they don't really care how you're doing it. And you can't really get the new technology adopted in your team because the directors don't care. But if you can get one person on your team to care, get them in a room, talk to them one-on-one, and get that person to see that what you're doing with R is helping so that you can stop crashing your computer 100 times a day with Excel, then you can start slowly building a support team behind you and what you're doing in R. And then those people can then start leading your charge with more advanced data analytical tools. So just get a few people on your side first, and then start building it.
Yeah, I totally agree with that. Yep. It also helps in your recruiting process, too. If you're recruiting new data engineers and they know several tools, including R, then you can have several tools in your back pocket to work with. And you can build sort of a level of legitimacy for your R work, having these people coming in who already know it. So it's you're building a team that actually has all those tools available to them and can use them to the best effect, especially if you can prove to them and to have your sort of your advocate in your company with you understand that it's actually helping. Yeah.
One thing that I thought, was that
Oh,
Sorry?
It's okay, she's waiting.
stepping down? One thing that I thought was impressive from your presentation yesterday was the percentage of time that the engineers at RStudio spend on open source development. So can you speak more about why RStudio continues to invest in that and the value that they see in investing in the open source resources?
Yeah, well, the company itself started as an open source company. We didn't have pro products for the first, I want to say, 4 years of the existence of the company. The founder's name is J.J. Allaire. He sat down one day and he said, you know what, there aren't any tools around R, and it's a really useful thing. Let me go see if I can build an IDE. So he did, and it was completely open source for the first couple of years. And it was only when we realized that people could actually use this in enterprise environments that we started building the pro products as well. So fundamentally, we think of ourselves as an open source company. And the goal is actually to support the R community. The goal is to help people solve really, really hard problems as easily as is possible with this set of tools, right? We're not going to find the cure for cancer, but maybe we can help somebody else find the cure for cancer. So we believe very strongly in that open source community. We like the transparency of it. And basically, when we sell the pro products, it funds our investment in those open source products with the eye towards making it easy to use, helping people solve their problems easily. It's a company with really strong values, and I'd actually also say very strong morals even to extend that. We would really like to see people have an easier time solving hard problems, not have to worry about your tools. Don't worry about the tools, just go after the data and find the answers that you need. So we do believe strongly in that. Over a quarter of the company is working on open source assets very happily. Both in terms of the R packages themselves, the libraries that help you work with data, but also with the open source tools as well. The IDE is completely free. We have free versions of a couple of the different servers as well. So for us, it is the mission, is to make R better. Yeah.
That's incredible.
I like it. I'm biased, but I love it. Yeah.
So pivoting over to your use of customer feedback data, did you find that data was useful in its raw form as it was being originally captured, or did you have to iterate at all upon that capture method in order to make sure that you were getting it in a format or getting the information from the customers you needed that was actually useful?
Yeah. So it was actually really easy to get the data out of the API. It was super easy. All of these tools have APIs or application programming interfaces, so it's easy to bring the data into one place. That was not the challenge. The challenge was the cleaning. So the data was either messy or in the wrong format, or some of it was missing. So there was a significant amount of time spent actually cleaning the data before you could play with it. Once you got it into that beautiful, tidy data frame where everything was in the right order and the right shape, it was really easy to work with. But the hard part was the cleaning of that data. Because it was coming from different data sources and different formats with different fields and different names, that was the bulk of the work, actually. But once you get that done, right, as the data expands, you don't have to do that anymore. That's a one-shot deal unless you have a new field coming in or something like that. So it was totally worth the investment because we've used the same code for 3 years and made all of these great observations out of it. So Yeah, there are good tools for it, dplyr and a couple of the other packages to be able to do that, but that was definitely the bulk of the work. And I don't think that's unusual. I think it's really common to have messy data in the world, and you have to try to make some kind of order out of it. And that's actually the bulk of the work. Once you get the pretty data frame, the visualization part of it was wicked easy.
Going back to your repeatability point with that, what do you do when the data source that you're pulling from may not necessarily be static, even backward looking, where it's something someone could go in and change it later? Do you recommend using data extracts, saving those data extracts? How do you balance the efficiency of having to store all that data versus being able to go back and get the exact same results if you run the code again?
That's a good point, because you aren't going to get the same results if your data changes underneath you. I mean, the logic isn't going to change, but if the data changes, obviously your results will. So it really depends on what kind of data you're working with, what your data source is. My data comes from databases and APIs, and it's okay if that changes, because I actually want to know what the most recent data is so that we can act upon it or measure it, right? See whether it's actually made a difference to any of the changes that we made. So in those cases, we have a scheduled report that pulls that data from the APIs, cleans it, and sticks it in an S3 bucket. Wherever you end up storing it is fine. In our case, that was just the most convenient thing. But that means that all of our applications can then look at that S3 bucket, and it never changes for them because they're just looking for a data file, right? So the applications don't care. And then this scheduled import brings it in, cleans it, and puts it back in there where the applications can then get to it. So we've solved that problem by kind of divorcing the acquisition of the data from the analysis of the data. But one of the challenges is your data isn't always available in an API or a database. Sometimes it's in a random file, sometimes it's census data that you have to download somewhere. That can definitely be challenging. The plus side of it is you have static data, so you're truly reproducible, right? Your data's never going to change. But if your data's never going to change, then you won't have the most updated data. You have to find some place to store it. That can definitely be a challenge. I don't really have an answer for how best to do that. It really depends on where your data is coming from. But for us, it was a compromise between being able to acquire it on a regular basis and having a static place where the applications could all look. So we just divorced those two things and have two different processes to keep that, to keep it in sync.
And do you have a recommended cycle for how often you go back and evaluate that reproducible code to say, is this still relevant to what we want to answer? Is there anything else we want to add? Is there kind of a balancing act there that you would recommend?
There is a balancing act, because when you want to measure, when you want to do the measuring to make sure that something worked, you actually need to run the same analysis. But you also have business needs that change. I have different sets of stakeholders for different kinds of data. And I have the same data set, but I have different people who need different things out of it. And so there is a little bit of a balancing act to, well, this one needs to remain static because people are relying on it to measure, but this one can be a little bit more innovative because we need to answer new questions. So as long as you're very conscious about those changes and you can relay that information along with your outcomes to say, look, we did actually change the logic here. Here's how we changed it, and this is how the graph has changed. We get, and we keep historical records as well, so you can say this is what it would look like in the old format, this is what it looks like in the new. As long as you're very transparent about that, there's not a huge amount of risk if everybody knows what the changes have been and why.
Right.
In our experience.
Thank you. I'm just curious at your company how you manage version control with your code and storage and working across people in different groups accessing the same code.
Yeah, absolutely. So we use GitHub. We check everything into GitHub as our version control to make sure that we do, we could roll back anything that didn't actually work terribly well, but also so everybody can get to it. So I would say probably 90% of our repositories are actually public. You could go look at our Shiny code. You could go look at our IDE code. We do keep the pro products behind in private repositories, and sort of my analysis is in private repositories because we wouldn't necessarily want the world to see our customer data. But everybody within our company can get to it. which at first intimidated me because I'm not used to having that many people look at my code, and I was new to R, so I'm like, oh, please don't judge me on this code. Like somebody actually mentioned in the talk, they're like, why are you using lapply instead of purr? And I'm like, because it was 3 years ago and I didn't know any better. But everybody has that, visibility, so I can actually learn from people who are coming in and saying you really should be using purr there. So everybody in the company, to answer your question, has access to that and can critique it and can actually look and see what I'm doing with it. But we find that while it's intimidating, we find that most useful to be able to get the kind of feedback from my colleagues. I'm lucky to work with really nice people who tend not to grill me on that stuff. They're trying to be more collaborative about it. But we do need GitHub not only so that other people can work on multiple projects, but also so that we can see the history of how those analyses have changed. So if you're like, why does this graph look different than it looked 2 years ago? You can actually go into the code and see exactly what I did to change it.
And how did you go about building those best practices on your team for getting people to check in their code regularly and well document things so that it can be used by others?
Yeah, so we cheated. We're a software company, so that's pretty standard, pretty par for the course. But on the data science things, I don't know if anybody's heard of Jenny Bryan, but she's she's on our team, and she's a package developer on a couple of our R packages, and she's a huge advocate of bringing software development skills into data science, specifically with R. So she has actually written articles and blog posts, and I think half of a book on using Git with R to make your life easier for precisely those reasons, that you can track and see where your analyses changed and how. So for us, it wasn't too much of a struggle, but we recognize that it is a struggle in other teams that aren't used to software development practices. And again, I don't think you have to be a programmer to be able to write code, but taking advantage of some of the best practices that have come out of software engineering will definitely make your life easier. For instance, if you go on vacation and drop your laptop in the ocean, your code's still somewhere safe, right? I mean, you have bigger problems if you dropped your laptop in the ocean, but you won't lose your code. So that in of itself is enough to get people to look at it. Plus, there's some really nice resources online for how to use Git and how to use Git effectively, so it's not too hard to learn if you find it important for your organization. And obviously, we do. So.
We have time for one more question.
Hi. In one of my recent classes, project management classes, my professor mentioned that in IT industry, in long term, it is very important to have expertise in like particular industry or domain, because he said that technical knowledge is transferable. So in the long run, you need to be expert in particular domain. So how relevant do you think that is to like data science, or like when you are a data scientist or a data analyst?
I'm sorry, I didn't understand. Can you repeat, please?
Yeah, sure. So my question is, how important it is for a data scientist or a data analyst to have domain knowledge or expertise in one specific industry or domain in the long run?
Oh, how important is it to specialize in an industry in the long run?
Yes.
I'm not sure I can speak to that. I've only ever worked in software companies. But data science is something, to my mind, that crosses industries. So having a certain set of base skills, I think, would help you in any industry. But that said, understanding what types of data that you have in a particular industry and understanding sort of the parameters and the problems that people are trying to solve in that industry, I think is really important if you want to stay in that industry. I think there are a lot of skills that you could translate between industries quite successfully, but having somebody with expertise not only in the technical side, but also in the business side, understanding the problems you're trying to solve, I think that's also really important too. I think it also depends on where you are in your career. If you're earlier in your career and you have a baseline of data science knowledge, I think you can go into a lot of different places. But for instance, if you're in the medical field and you happen to know say, radiology imagery really, really well, then if somebody's looking for somebody with that expertise, you've got a leg up on everybody else in the field. But if you're looking to change industries, I think as a data scientist, it might be easier for you than any of your colleagues to change those industries because of so many of those skills are translatable. So I think it really just depends on what you're going for.
And I think we're out of time. Thank you so much for sharing your expertise, Amanda. Thank you for putting code in your slides. A lot of us were really excited about that, I think. Yeah. So, and thanks everyone for a great Q&A.